The Casper Planetarium presents the Western Skies Podcast. Today's episode, Constellations, Patterns of Illusion. For our ancient ancestors, the sky was a dome that arched over their heads. The sun and moon rose in the east, traced an arc across the sky, and set in the west. At night, the stars wheeled overhead in a similar pattern. Because the position of the stars relative to one another remained constant year after year and century after century, it was surmised that the stars were fixed to a gigantic crystalline sphere that surrounded the Earth. This sphere of stars became known as the celestial sphere, a term astronomers still use today. The consistent position of the stars led every culture on Earth to connect the dots and form patterns in the stars that we call constellations. This model of the heavens works really well for observations made by the backyard astronomer. But modern astronomy has shown us that the constellations that we see in the night sky are mere illusions, perceived patterns based on our observation platform here on Earth. Take, for example, the asterism known as the Big Dipper. Composed of 7 bright stars, the Big Dipper is one of the most distinctive star patterns visible from the northern hemisphere. The stars of the Big Dipper all appear to be about the same brightness as seen from here on Earth, a property astronomers refer to as apparent magnitude. This would tend to make us think that the stars are all the same distance from Earth. For example, think of car headlights. At a distance, they are much dimmer than when they are up close. But if we move to a position far from Earth, we will see that the stars of the Big Dipper are not all the same distance from Earth. The closest star, Megrez, is only 63 light years away, while the star Alkaid is a whopping 210 light years away. So clearly, the distance to a star does not necessarily indicate how bright it looks from here on Earth. How bright a star looks depends on 3 factors. The first is, obviously, how close it is to us. The second is how intrinsically bright or luminous it is. And the final is how large or big in diameter the star is. A close star might not be visible if it is small and dim. For example, the Barnard's star in the constellation Ophiuchus is only 6 light years away, but it is only visible with the aid of a telescope. This is because, while close, Barnard's star is a small red dwarf star, meaning that it is very small and cool compared to the Sun. Barnard's star is 4/10,000ths less bright than the Sun. Compare that to the star Sirius in Canis Major. Sirius is the 6th closest star to Earth, but it is the brightest star in the sky. This is because Sirius is almost 2 times larger than our Sun and 23 times brighter than the Sun. But what about a star that is really far away? The star Betelgeuse in Orion the Hunter is a cool star like Barnard's star, but it is more than 10,000 times as bright as the Sun. This means that Betelgeuse is really huge. If placed in our own solar system, the surface of Betelgeuse would stretch well beyond the orbit of Jupiter. So how far away is Betelgeuse? We've already seen that closeness does not necessarily mean brightness, but Betelgeuse is easily visible during the winter nights in the shoulder of Orion the Hunter. It turns out that we can calculate a star's distance if we know how bright it looks from Earth and how luminous it is. Using a little math, we discover that Betelgeuse is about 520 light years away from Earth, considerably farther away than Sirius in Canis Major. This is the same reason that the star Alkaid in the Big Dipper is so big and bright in the sky. Even though it's really far away, it is a big, hot, luminous star. So the next time you're looking up at the night sky, remember, the patterns we see in the sky are illusions created from our innate ability to see patterns. And the stars that are so dazzlingly bright may be unimaginably far away, and the closest stars you might not even see at all. For the Casper Planetarium, I'm Rod Kennedy. Thank you for joining us.